Okay, good evening to all. Can you hear, Dr. Branch?
Yeah. We could hear you.
We will start now.
Yeah, we will start.
Okay. Good evening to Dr. T. Niraj, our resource person of the event today. Good evening to the participants. Today, IESL Clean District Center organized an event on building information modeling in practice. First of all, I would like to introduce our resource person, Dr. T. Niraj. Dr. T. Niraj is Associate Professor in Built Environment and he is the head of the department in the Architect and Built Environment in Northumbria University, UK. Dr. Niraj graduated from Department of Building Economics in University of Moldova in 2002. And he has completed his PhD at University of Salford in UK in 2012. Dr. Niraj's research covers people and process related aspects of the built environment, including how organization and peoples work in the context of technological innovation. He has worked with a number of organizations on research projects, including Wilmot Dixon, KPMG, AHR Global Architect, and etc. He has peer-reviewed more than 60 publications and managed several research projects such as ORBW, ACBW, etc. I would like to hand over the Zoom platform to Dr. T. Niraj in order to start today's session. Thank you. Dr. Niraj, you can start today's.
Yeah. Thanks, Raghunathan. Thanks, everyone. Thanks for inviting me to this. I'm good. First of all, good evening. This is a slightly time difference. I'm in the UK. You are in Sri Lanka, probably most of you. And I think I'm really glad to be speaking to most of the fellow Sri Lankans. I hope you find this useful. Before I go in, can I quickly check whether, can you hear, can everyone hear me? You can put the hands up. Yes, anything would do. Can you hear me?
Yes,
yeah?
I can hear you.
Okay, brilliant. Thank you very much. So today I'm here to talk about building information modeling in practice. So we will introduce the idea of building information modeling and then go into how it is done in practice, some of the challenges, some of the issues. I've been doing this building information related research probably more than 10 years. So there's the knowledge is built over various different projects, various different participants and companies. So you would see that throughout. But my experience is very much in the UK and not in Sri Lanka. But however, I have worked with some of the Sri Lankan colleagues in terms of using BIM, but in a slightly different level. So I'll talk about those things. I hope at the end of the presentation, I'll open up the floor and hopefully we can discuss things. I think that's more interesting and informative for all of you. So, and depending on where you are working, what sector you are working, this applies differently. So we'll see how that works. So let me first of all find them in the correct place to start the presentation. Okay. Hope you can see this, and so I'll start with that. So for today's presentation, so I'm going to cover what is building information modeling and modeling, and then go into in practice how it is done, how it impacts professionals, their day-to-day work, and then what are the challenges and the changes that it requires. So if you're an engineer, your role is going to change if you start using building information modeling. So how will that change? What sort of changes would you expect to happen in the coming near future? Something we'll discuss, and what are the future directions? And we'll have a Q&A that supports those things. And I think this is very important. In Sri Lanka, there is no mandate at the moment to use BIM. So not everyone uses BIM. So we'll go into the, into the presentation to see why we should use BIM or what are the potential and advantages of using BIM. But not everyone needs to use BIM, so I think at some point you'll come to that. I'll start the presentation and I just want to make sure that there are two raised hands. Can I just check whether they are questions or whether they were raised hands before because it was the hands raised, the initial one. Okay, I hope they're not questions. If you have any questions, please do type at the moment so that I can see the questions and I can answer when it goes. And of course, we do have a question and answer session at the end of the presentation. So let's see, what is building information modeling? By definition, it is defined as a set of interacting policies, processes, and technologies. It's important that a lot of people see building information modeling as a 3D model, a visual model, but it is more than that. I think that's very important to take. I see a lot of 3D models of houses being printed on newspapers in Sri Lanka. They are not BIM models. They are just digital models to show what it looks like. They are not BIM models that has information behind it. They just look like a model so that you can, people can get, it's more of a seduction of, what you're trying to buy rather than actual information behind it. That's important for you to get that. So building information modeling is the policies, processes, and technologies. And most importantly for me is a way to manage building design all the way through building life cycle. So we are not just talking about design, we're talking about design, construction, so design in terms of architectural design, design in terms of structural, mechanical engineering, and other designs. They all get together to design, then build a building, construction of the building, or construction of the asset, if it is an infrastructure facility. And at the end of the day, it's about, once you're finished, it's about maintaining, managing, and maintaining the operation of the building. So it follows throughout a building cycle. I think that's very important for BIM. A lot of people take a technology view, BIM is a technology. I think that's not a wrong thing. It depends on where you're coming from. So in practice, if you are a software vendor, you will think about BIM as a software, as a product. Some software vendors will say Autodesk is a BIM. Autodesk is not BIM. Autodesk allows you to model some of the BIM things, but it is only one of the products that can be used. If you are in infrastructure, you would have heard the term Bentley. Bentley has a series of products that can be used to create BIM models. Again, that is another software. It's a product, but it could be used to do this work. So that is a view of vendors and people who are trying to sell the product. However, I think if you are a technologist, your thinking is that BIM is about modeling. I'm going to model a building. I'm going to model a window, or I'm going to model a part of the building. And that is how they see it. So depending on how people are, and you will take a slightly different view. If you're an engineer, if you're a manager, project manager, you would see BIM as a system that allows you to connect different things all together in one place. Normally, if you're working in a project, you get a set of drawings from architect, a set of drawing from a structural engineer, a set of drawings from an M&E contractor, M&E engineers. And what the problem that you see is that they are not actually, they're not in the same place. They are all in different drawings, different models, different places. So trying to bring them all together into a single system so that you can see the problems and challenges is where probably as an engineer, as a project manager, probably you would see. So system is probably my closest view, is more of a system. Probably you would see that as a system as well. Now for contractors and for governments and major house builders, this is a business opportunity. They see it differently. So why is it a business opportunity? It's a model. What is it going to do at the end of the day? And that is very important for us to understand. So I'll go into that a little bit. In the UK, the government has mandated the use of BIM. So if you have a government-funded project, you need to produce a BIM model as part of it. We are going to talk about it why, but that is government mandate. Now, several other countries around the world have also got mandates, and they are all starting to push BIM to be part of this model that is being provided. So at some point, and I know there are some discussions happening in Sri Lanka at high level in terms of whether there will be, this will become a mandate, but at some point this will become a necessity for all of you, all of us. And I think that's important. It may not be necessary for all activities that you do, but maybe necessary for certain activities you do. If you are planning to go to other countries to work, for example, Middle East, most of the Middle Eastern countries have mandated BIM as part of their projects. So it is going to be important for you to get to know, use it, and understand these things. The new large projects coming in Colombo, I know they are starting to use BIM, but I'm not sure how widely used this is across the country. But it is something that we know it is going to come if we are going to have bigger projects and projects that builds with other things. The question still remains, why are we doing this? And what is the purpose of this? And this is where the parts of these things comes in. It's an opportunity because it fixes some of the information related problems. Sometimes you would have seen this one, you submit, people submit drawings, and you would see one set of drawings will have 20 millimeter duct. The same drawing in a different place will have 20 centimeter duct. It's the same drawing, but different information because people are misinformed or they actually wrote it wrongly. But the problem is that we don't know which one is correct. So this is a major problem when it comes to information supply at the moment. This fixes, in some way, it fixes some of these issues that you have. It also allows people to come together, talk about these things, and work collaboratively when it comes to projects. Normally, the designers work separately from the contractors and the architects, and if architects are involved in it, or service engineers are involved in it, they work separately because they are different companies, do different parts. This allows everyone to come to the table, talk about a single thing, not different things when they're talking about it. So on the long run, it allows us to design more effectively and produce the building more effectively. I think efficiently and effectively, I think that's important. So at the end of the day, when you produce the building using BIM, you have a building as well as an information model of the building, a digital representation of the building. And therefore, it is more than a building. It's not just a building. It's more than a building. It allows you to understand the information within the building and use that information on a longer period, not just only construction, even after construction. So it adds greater value to the project that we are, or the buildings that we are talking about. Now, government sees them. So this is from an engineer's, from a contractor's point of view, but governments see this one differently. Now, governments see this as something that allows people to communicate with other sectors and other buildings. So they are not just talking about a single building. They're talking about series of buildings. So let's say Ministry of Justice decides to bring all the buildings in Sri Lanka on a digital format connected to each other, so that there is a standard for each and every building. We know when something goes wrong in a building, we know what is going wrong in the building. So governments normally, so in the UK, there was a report in 2015 called Digital Build Britain. That particular report talked about how different industries can come together. So you have a building and there is a problem in the water supply. Yes, it's a building related problem, but it is also a water supply related problem. Ability to identify there is a problem and then connect with other industries is very important. So the idea for government is to use Internet of Things. So you would have heard sensors. So put sensors in the building. without connecting sensors to a model, they're just sensors that produce numbers. They have no meaning. So once you have sensors in places attached to a model, then you know in a digital representation what sort of information, the information about the building on the model, live data on the model. So when there is a problem, then you can identify and do those things. And you can see that is where this Internet of Things, Internet of Smart Construction and Services come into play. They then enable, so building information model is almost like a building block. You have a single building with information model, second building information model. So if you have almost all the buildings in the place with building models, then you can connect them to create a smart city, a smarter environment, so that you can easily manage, you can optimize the use and running of that smart city. So that is what governments want to do. And that's where they're starting to push BIM as the building block of each and every small buildings or assets, infrastructure facilities that is coming into play. So they can build the whole nation in a way, smart cities and the whole nation into what we call a digital representation, or sometimes people nowadays call that a digital twin. A twin, a digital representation of a physical environment. By doing that, you can manage those things. How do you operationalize this? So the report again goes into further details. It talks about, if you see this, this is the actual delivery of the building. So you do that as a building, single models, a group of buildings digitally modeled, and then the city modeled in digital, in the digital environment, and the whole nation modeled in digital environment. Once you have those models, you are then able to provide sensors to understand what is happening in each and every building, between buildings, between assets, infrastructure facilities. So when there is other issues and challenges, then you can talk to the people who are in charge of power, people who are in charge of water, people in charge of transportation. So the different industries can come together in producing what we call an optimized solution in running the built environment. At the moment, that is not how it works. So the idea is to move towards a much more digital environment. You can see BIM at the moment, when we talk about it, it's a single model, a single facility, a single project. We're talking about how to implement, how to use it. But from a government point of view, it's a group of buildings or cities or nation as digitally modeled and managed for optimization and day-to-day running of those facilities. So that is why the governments are pushing around the world, pushing to this, for this to happen. And part of that is to understand how a single model works. Now, I don't know this answer. I'm going to ask a silly question, so you can type your answer, or you can just to see how many of you have, have you been already involved in BIM projects or building information modeling in any way? Anyone who is involved in it, because I know there's different levels of understanding. So just trying to understand whether anyone is involved in BIM projects. So if you could type your answer on the chat box, I appreciate that, so that I can then take it and then give you a bit more, a specific answer. Sorry, is it? Okay. Okay, so let's talk about building information. I talked about why we need to do building information modeling, why governments are pushing everyone to do building information modeling. But now let's talk about what we can do with it, what to do with building information modeling. So we are going to talk about how to implement and use this. Okay. So I'm going into this idea, building information modeling. We are going to talk about implementation. How do we use building information modeling? I'm going to take 3 different perspectives so that I can go one by one. I'll talk about, first of all, product perspective. I'll start with the process perspective. I'll move to the product perspective, and I'll talk to the people perspective. There's a comment, and I quite like this comment, trying to understand positives and negatives for building information modeling. And I think positives are overwhelming, but at the same time, I think it's important we understand the negatives, understand the challenges to move forward. Because I believe at some point it is going to happen to all of us. So if you are an early starter, you have an advantage. I think that's important. That's how I saw it, and I see. Nowadays I do various different things because I started early on building information modeling. Okay, so let's go into the process perspective. So building information modeling normally adapts a perspective called integrated project delivery. We call it IPD. The idea is that it is slightly different. It is different from the traditional delivery. And I think it allows you to bring the project in a much more shorter time. Some of you may use the term novated design and build procurement method. It's very similar. Novated design and build, DNB, is very similar to integrated project delivery mechanism. So what is this? What is this method? In a traditional settings, what happens to us is the client talks about this is the type of building or the asset that we want. Then architects goes and talks about it, gets that information, puts it into a drawing, pass that on to the structural engineer. Structural engineer does structural work and pass it on to the next person. So like that, it goes on from one person to another person. The people don't come together. They don't discuss things together. They don't find an optimized solution, but rather they find the best solution for their own activity. So when you come to the end of the project, you got a solution that is optimized for what architects want, what the structural engineers want, certain or M&E engineers want. But the challenge is that they haven't actually thought about a solution that is optimized for all of them. And this approach is called over-the-wall approach and seen as really a bad way of doing traditional, way of doing projects and traditional, construction projects. But you would see more of these things in Sri Lanka, not just only in Sri Lanka, even in the UK, it's the same story. There are projects which uses very similar models. But a lot of people have recognized that this is not working. This over-the-wall approach is not providing optimized solutions. So they want to break that, and they come to a much more collaborative environment in which they can work. So they move on to something slightly different. So I'm comparing two things, a traditional design process against integrated design process. In the traditional design process, what happens? The client and the architects work together in talking about what is the project. So that area is about what is the project at the very beginning. Then they produce construction drawings, and construction drawings show how they are going to do the work. And then they go to a tender, select a contractor, and then ask the contractor to finish the work. So that is the traditional way. What is the problem here? We are deciding on what we are going to build without any understanding of how we are going to build or who is going to build. And that is a problem. So integrated design allows something slightly different. What it shows is that at the very beginning, instead of just designing your project, select a handful of contractors. Maybe it's only 2, maybe it's only 3 contractors. So you go through a process at the early stage process to select few contractors with whom you can then work together. The client, architect, and the contractor start working together in producing solutions. So at some point in the project, at the tender stage of the project, you have now 3 designs with 3 different, if you have selected 3 contractors, 3 different contractors on how they are going about this particular project that you wanted. Let's say you wanted an auditorium. Different contractors will come up with different solutions working with architect. They will not be that much different because architect is there to sort of guide them towards a particular end goal, but there is different solutions there. So at this point, you will buy out a contractor among those 3 contractors whom you have worked with. You will be losing some money because you are working with 1 or 2 contractors for a few more hours, but it would have allowed you to develop a solution that is much more useful, much more, has meaning towards what the client wants. So that when it comes to building, we know the contractor knows who is the contractor. From the very beginning, they got involved in it. So they can't say no, and they know what they are going to build. And they have developed with the architect and the client on how they are going to build. So the building of that particular stage of that project becomes much more easier. And this is called integrated design delivery, integrated project delivery. And most of the government projects in the UK, in US specifically, is moving towards this sort of delivery because it allows people to start early and do various, to realize the potential of the project. There is also a slightly different reason for it. This is called McClerney's curve. What it shows is that if you see number 1, which is this white curve, white line, is almost hidden. What it shows is that if you do changes at the very beginning of the project, it has a huge impact on what it's going to look like at the end of the project. If you want to change things at the end of the latter parts of the project, it has very little impact on what you're going to produce as a building. So try to do the changes as early as possible. Now, in terms of cost, at the early stages, it's very little to make the changes because no one has done any work. It becomes very expensive to make changes at the latter part of the projects. So that is number 2. So they have mapped the traditional projects against IDP or the integrated project delivery, and they show that actually you spend less because you make the changes at the early stages and you have more impact on the design from the early stages. And therefore, overall, you produce a better project. So hence, people are advising to move towards a much more integrated project delivery. So that is a process perspective for building information modeling, because that is what most of the governments, especially in the UK, US, and Middle East and various other countries, are trying to push much more integrated way to approach the building information model used projects. Now let's take a product perspective. So let's talk about BIM as a technology, as a digital tool that you can use. So a lot of you would have seen BIM as a digital technology, as a software that you can use. Remember, they are all sort of combined together, so it's not separate. But when we separate it and look at it, probably this gives you more meaning if you're thinking about BIM as a product, as a software. So what does BIM as a software enables you? So what normally happens in modeling or in drawing is that you have different sets of drawing coming from different people. Similar to that, in models, it's the same story. There is an architectural model, there is a structural model, there is a mechanical model, sometimes there is a separate plumbing model or electrical model. So sometimes there are various different types of models. I remember I worked on a project, it's not a big project, it's a small project, but they had 7 different models, and one of them is the model from the specialized lift contractors, because they had their own model, own BIM model, designed on how things are needed for them. Now, the thing is that you can look at them, you can print out separate drawings for all of them, but the problem is that they are all separate. How do you imagine them all together in a single 3D space, a single environment? Normally, as engineers, you would do that thinking. You would bring that in your head. Okay, this is how the architectural drawing is going to look like. This is how the MEP is going to look like. Or this is where the wire is going. You are thinking, you are imagining that in your own mind. It's very difficult. And normally you wouldn't see that in drawings, how these things are presented. They are not presented in drawings. So it's always a difficult thing to do. And how many times you would have seen where a duct, a pipe coming together in the MEP design shows that it has to cut through a column and go to the other side, because people haven't decided on the size of maybe the duct, so that later the duct got bigger. So it looks like in the drawing, it looks like The duct has to go through the column. And as we all know, it can't happen. We shouldn't do that. Otherwise, the building will come down. So the idea here is to bring all these models in a single environment. We call this a federated model. So 3D model, there's a 3D model for architecture, a 3D model for structural engineer, a 3D model that represents mechanical, electrical, and plumbing work, and various other 3D models. We bring them all in a single environment. So now we can see where the columns are, where the windows are, where the walls are, where the ducts are, where the air handling units are. All those things are within a single environment. We call that a federated model. The idea is that you design them, bring them together, and work in that environment so that you can see problems when they are clashing, or you see, how you can optimize those things. Once you have the federated model, you can do lots of things with it. And it allows you to identify problems in the models, or problems where two models are clashing. Now, this is before construction or during construction. Now, even after construction, you can use this model to make it into as-built model. So this is what we have built. This is how the built model looks like. And the facilities managers then can use that model for facilities management purposes. So this model is not just for the purposes of designing, it's also for the purposes of construction. It's also for the purposes of handover, because normally nowadays the models are provided at the end during the handover period. Once it's handed over, then it can be used for operational and maintenance purposes of the building or the asset. So you can see it goes beyond just a single model for a particular purpose. It can be updated and it can be used for various other things. So this is how the technology and the BIM model works. Now in the UK, now this is widely accepted across the world, but in the UK, this is how we define levels when it comes to BIM. If you are using paper, just paper and nothing else, and we call that is level 0. When you are in level 1, you are using 2D and 3D drawings or 3D models, 2D drawings and 3D models, but you are not actually connecting it. For example, you are not putting these models together. I talked about 3 different models or various different models coming together in a federated model. That doesn't happen in level 1. It's just single models, people producing for various different purposes. This is where, I talked about in newspapers, you see a digital visuals of housings and things like that. I've seen in Sri Lanka. And they are 3D models. I call them, they are dumb 3D models because there is no information behind it, because they just look like a building, that's all. And that is level 1 in that sense. Now, level 2 is what normally we are pushing everyone to move to, is where you have models where you have information behind the model. So when you have a 3D model, when you have a window, when you click on it, you know it's a window. You know it has what sort of a glazing that it has. Things like you can get information about each and every product component in a model. And that is the BIM-based design. And that is the level 2. So we are, at the moment, we are proposing the level 2 to happen. Now, level 3 is where we start integrating everything else. You remember I talked about digital built Britain earlier. I talked about the models connecting with other industries. You put sensors in, let's say you put a sensor in a water pipe so that you know the flow and the problems in that flow. Let's say after some time, just suddenly your sensor is telling the flow is reduced between this point and a particular other point. So you know there is a block in between. So things like that can be done in the next level. That is level 3. So that is where the governments wants to move. That is where the next stage is. The current stage for most of us around the world is level 2, to move from 2D models to 3D models to models that has information behind it, intelligent models. And that is where we are talking about moving towards a BIM modeling. So what are the benefits of these models, the using building information modeling? Someone asked, what are the benefits and negatives and positives of it. First of all, the idea is, as people sometimes say, it's a single truth, meaning that everything is in a single file so that you can always go back and say, this is where the information is. This is important for us because normally you see information, different type of information in different places. Single file allows you to bring all of them in a single place and provide that information to be shared. And that's very important. Second one is parametric objects. What do we mean by parametric objects? So let's talk about walls and windows and ceilings. So if you have ceilings and walls in a AutoCAD or CAD model, you put a sort of a wall all the way where the ceiling is, so that it's 4 meters, and on the top the ceiling comes in. Let's say in the model, you say instead of 4 meters, not 4 meters, instead of 2 meters, you say only 1.5 meters, but the ceiling is at 2 meters, meaning that there will be a gap. That's what you would normally imagine in an AutoCAD or CAD environment. In a BIM environment, what happens is that each and every component, such as wall is one component, ceiling is another component, they all share a relationship. For example, if you lift your ceiling by 10 centimeters, all your walls will automatically extend to fill that gap. You don't need to do it one by one, because there is a relationship in the BIM model that says the wall should be connected to the ceiling. So if you lift the ceiling, the wall will automatically extend. You can stop it if you want to, but normally it will extend because that is the nature of parametric objects. So for example, you have a window, you try to put a window, it automatically will cut the wall in such a way so the window can fix in. You take the window out, the wall will try to cover that, because idea is that wall needs to be fully sort of connected. So that is part of the parametric modeling. So BIM, so if you go for 2D CAD drawings or 3D CAD drawings, you will find that it doesn't have parametric relationships. It doesn't know that the software doesn't know that wall needs to be connected to the ceiling. So whatever you design stays as it is. But when it comes to parametric modeling, it will extend and it will connect together. I think that's very important as part of building information modeling. Of course, you have a single file, but you can take any, I'm moving to the third one, you can take multiple views out of it. You can take a plan view, you can take a perspective, you can take a cross-section, you want to take a detailed version of a part of it, you can zoom in and take that one. So you can take multiple views from the objects, so the buildings that you have. So that's an important one. The next one is analytical. So BIM produce an analytical model. What do I mean by that? For example, if you want to do a calculation for sustainability, how much carbon are we spending on this? What sort of a cooling or heating is needed in this place? You can do that analysis through the model itself. There are softwares that will use the model, take that one and do that analysis. So it can allow you to do that analysis section. But I think for me, most important of all these benefits for me is clash detection. So what is clash detection? I don't know any one of you whether you have played games when you were young, maybe 20 years back when you played games, the games were different. I remember playing a game where you were playing as a police, you need to shoot the robber. And as you know, those days, everything is like a pixel by pixel. So if a robber, a thief is running one way, you are shooting at him. What happens is that the bullet travels from one pixel to next pixel. You can see traveling it. And the whole idea is that if the thief and the bullet that is traveling from pixel to pixel meet at the same point, the robber will die. So the idea is that you are shooting because it's going in a pixel format. It's a very similar idea, to be honest. The clash detection is that if two models or two components are sharing a point in the digital model at the same time, then there is a clash. For example, you have designed your MEP designer has designed a duct, and your structural engineer has designed a structural model of the building. Now you have put the structural models against MEP model, against architectural model, everything in one single federated model. When you run an analysis, you would find that if you find that a duct is going through a column in the digital environment, you know that it can't happen. You can't cut a column, a duct can't cut through the column. So we can't do that. What happens is that in the digital model, it will identify that this is happening. It doesn't leave it for the contractor to sort it out. Now, I don't know about you, but I have worked in projects where and I'm talking about UK, I'm talking about UK, where projects where the contractors, I remember at this particular, in the morning briefing, we are all talking, and there's the MEP designer is a contractor is putting the duct. This is a duct with a fan and the air handling unit. The duct, and he's looking at the duct is actually almost next to the column, not next to the column. It's cutting through the column. So he said, we can't do this. We can't cut through the columns. How do we do this? So the supervisors and the contractors' suggestion was, okay, don't cut through the column, just go around the column and follow the same path. So we did that. But there are problems because of that, because the design for the fan and the air handling unit is not for that turn. It's a straight line. Once you turn it, the air handling unit and the fan is not producing enough heat or cooling, in your case, to that environment. So it becomes a problem. But everything is hidden above the ceiling, so no one sees it, so everyone is fine. But it doesn't work, because when it comes to occupy the building, then there is a problem that you find that particular fan is not working or is not good enough. So you need to increase the heat or increase the temperature through your normal things. So it is a problem. So how do we identify this problem before the contractors comes to the site and address those things? And that is where the clash detection is a brilliant way to identify. It solves a lot of problems for the contractors and engineers who are trying on site, trying to deal with these things. Because day to day, you see these problems and say, why is this? Why didn't anyone pick it up? They didn't pick it up because they are all in different drawings. They are not in a single environment. Once you have a single environment, it allows you to identify those things. So that is clash detection. And on top of that, you can, of course, do operation and maintenance of building using building information modeling. So these are some of the key benefits of using BIM. Now, if you are interested in knowing more about BIM and to understand some of the guidances around BIM, so look at this. This is the main standard. I'm sure everyone around the world can access this and download this. It's free. You may have to register, I think, with your email address, but it's still free. It used to be PAS 1192. That is the number under which all this BIM guidance was provided. However, it is now has become a standard, a recognized ISO standard, and the standard number is 19,650, ISO 19,650. So look for this, and it will give you all the other standards and what people are doing, how you need to design, how you need to name certain files and things like that. It provides all those things for you. So if you have time and if you want to know more about it, get hold of these things. But what are these guidance or these standards are telling you? I'm not going into the details. Just a simple explanation, a little bit about what it talks about. So as you know, at the very early stages, when you want to build a building, you have a client brief. A brief talks about what is the building that they want, how it is going to look like, what sort of a performance is expected out of it. Now, for the BIM purposes, we have what we call employer information requirement, So it talks about what sort of information is required by the employer once the project is completed. And I think that is the start of the BIM process. So clients normally ask this one. Once you have that one, then the client and the architect and the design team will work together in producing what we call BIM execution plan. What is BIM execution plan? A BIM execution plan talks about, for example, it talks about what sort of a detail is needed for a design. So if you're talking about a window, you talk about when this window design is needed. Can we just put a window like a box? Do we need to decide what sort of handles are needed? In what stage, what level of information is needed? And that is what is designed by BIM execution plan. And it provides further other details in terms of how it is done, when it is done, what sort of information, who's providing that information, what level of information, and things like that. Now, then we go into construction, you have a master delivery plan. And then in the UK, it is the contractors and the consultants are guided by certain outputs of information. At different stages, you produce different sets of information. And at the end, you produce an as-built information. That is the as-built model, BIM model that could be used for other things. So it talks about various different things in that project, in that standard. These standards provide that information. So I'm not going into full details of it because we are mainly talking about what this is, but this is much more detailed information of what needs to be done when you are using BIM. Now, the important part that I'm going to talk about is I talked about process perspective. We talked about IDP, integrated project delivery as the process behind building information modeling. I talked about the technology and the product view. What sort of a technology, what could be used, what sort of details and things like that in the earlier section. Now I'm going to talk about the people perspective. I think this is very important. The idea of whether you want to use BIM or not to use BIM is very much a people perspective. It's very much perspective from people who are in the project, the client who is running the project. So that's very important to understand. So we are going to take a people perspective in this case. Most of the, if you are new to building information modeling, most of the time people, a bit of a confusion, and people normally avoid it. Oh, I don't want to get involved in building information related projects. This is not going to do anything good. It's just information and people can take this information and run away. I worked with a lot of quantity surveyors and they say, if I put information, people will take that information and use that information somewhere else. And that's not true, but that's how they think about it. So it's quite difficult. This is where we start. If you are not used to building information modeling, it's a change, it's new, so it's always a bit of a difficult thing. So that's where we start from. And of course, there is a hype behind BIM. A lot of people talk about BIM as something big. You can do that and things like that. What is happening with the BIM in the UK and other places is that there was a big hype in early 2010s, 2012, 13, 14. But then it reduced, and now we have settled down and said we need to use BIM. How do we use BIM? So we have come to that stage now. The hype has sort of gone down. At the very early stages, it's a major hype. It's nothing major than that. So it's important to understand that certain products could be hyped, and it's important that we go beyond and look beyond that hype to see what is its potential and how do we use that one if needed. I think that's important. The problem with BIM is about managing the BIM use. I think that's very important. If you are working in a BIM project, it's about how do you manage to make BIM work. I think that's also very important. It's just a model. It's just a process, a set of guidelines. It's not going to do it for you. So how do you then work with BIM and other people in making it work? I think that's very important. As you know, people are different. Everyone thinks differently, works differently. Every organization is different. In a project, there are several different organizations. And as professionals, you are involved in various different tasks. And information that you handle in each and every task is different. Some of them are geometrics, different types of information comes to you. Now, so you can see how chaotic it would be when we are trying to work in this environment. So that's why it is important that you manage that environment to work. So normally in the UK, we have a BIM manager for projects who normally manages information when it comes to building information modeling and its connection to projects. It's important that it is managed well. Now, when you think about people, normally we talk about people in two different ways. You know, there are structuralists who see the world in a very structured manner, and there are people who are adapters who think about sensing actions, and they talk about solution in a much more judgmental way. So there are more adapters and there are structuralists. If you are an engineer, normally you are taught to become a structuralist. You may not be a structuralist, but you are taught to think about things in a very structured, methodological way to handle things. So flow charts are your day-to-day activities. You know, calculations are your normal ways of doing things. But I don't want to stereotype structural sort of engineers in such a way, because I have worked with engineers who are much more adapters. So it's not easy to say, you know, it's not a general view. However, most of the engineering courses allows you to, or makes you to think in a very structured, methodical way. I think that's important. That's what your learning goes in. And when it comes to tasks, there are tasks that needs judgment. So, you know, you judge certain situation, look at the people and make a decision. And there are calculative tasks that allow you to say, or what is the size of the column, or what is the size of the reinforcements that you need to put in this particular column. That's very much calculative part. As part of your structural, your learning as an engineer is partly about calculations and how to calculate those things. That doesn't mean that you are not making judgment, but there are a lot of calculations involved in it. Building information modeling is a really good tool for someone who's more calculation oriented, as well as someone who sees the world in a much more structured manner. So for most of the engineers who are taught in a way that is, you know, calculation based and much more structured way of learning, BIM is an ideal thing to look at. But that does not mean that you are not adapting or judgment. Then this is where that is important, that you work with people and understand how to make judgment when the calculation doesn't work. You know, not the standard tables don't work sometimes because the situation has changed. So you have to come up with new calculations or you have to make a judgment from what your calculations. So it's important to see the world differently in that sense. Now, the important part is don't try to use BIM for everything. I think someone asked this question. I'm trying to understand what are the negatives and positives. Should I use BIM? I think it's very important. We don't use BIM for small tasks. We don't use BIM for things, you know, and it's important for you to understand that BIM is not appropriate in every situation. If the situation is very chaotic and complex, BIM will allow you to structure it. If the situation or the project you are looking at is simple, sometimes using BIM could make it more complex. So it's a judgment call for you to see whether you want to use it or not to use it. It's important, you know, don't try to, you know, it's like, you know, I have a hammer and I want to use the hammer. Where can I use it? Let me crack that one. Let me crack this one. And it's important that we don't go, you know, use BIM in that way. We have BIM. Where can we use it? That's not the question. The question here is that, does the situation need building information modeling? Will the building information modeling allow that project to be better? I think that's a question, a judgment call for you. In the UK, the government says that if you are spending more than £5 million in a project, that is a complex project. And therefore, using BIM will allow you to make it better. So it has put a cost target rather than complexity, but it is your judgment. I don't think that's easy as 5 million, you know, it's more of a judgment call in terms of where to use it and where not to use it. So that is very important to understand. Okay, so I hope this provides a bit of an understanding for you on what is BIM, where BIM could be used, how we could use BIM, and how do we deal with the process, people, and product sides of building information modeling. Now, the question sometimes, and this is an interesting one. I worked in a project, and this was their first project. And the project manager said, provide all the information that you have. and everyone provided information. And later they found out there's so much of information they couldn't make head or tails out of it. So the second project, they decided they are going to specifically ask certain information. So it is important for us to understand, the BIM could be used in various different projects, and it could be used in various different stages for various different activities. It's all about information. It's about understanding how that information is used and what benefits you can get out of that information. I think that is an important task. In a project environment, when it comes to building information modeling, remember, building information modeling is only part of the project. It only provides partial information of the project. It is not the project, it's a 3D environment. I have seen project managers trying so hard to manage the BIM model, they forget to manage the project. It's important, project is separate. Physical environment need to be managed on its own. The BIM bits allows you to manage it better. Don't try to manage the BIM on its own. So that's why normally we suggest bring a different person to manage BIM, but their work, if the project manager and engineers and the architects don't understand what is BIM, then it cannot work. So that's why the understanding is important from the point of view of engineers, as well as from the point of view of the project managers and the modelers and the information managers. So that's very important for us to understand. The most important part for me here is that BIM only provides a partial view of the world. And therefore, it is important that we see the normal project as a project and only see BIM as a partial information. And that is very important. Some of the concerns and issues that I found, and I'll go back to this a little later, some of the overall things that we found out is sometimes there's an issue of interoperability. So you're working on one version of the of a software, and you transfer to a different version of the software, suddenly windows are missing or staircases are missing. And I think that's a problem. It's becoming better. Now there are much more rules about it and common platform in which you can transfer. But if you're using old models, that could be a problem. The famous example is that, there's a French software called CATIA. It allows people to model, parts of aeroplanes, the Airbus, one of the Airbus, the problem they found in the Airbus in the design is that they used two different versions of the software and ended up missing certain parts, and that ended up in a major information related problem. So it is important to watch out for interoperability related issues, interoperability between different softwares and different versions of the softwares. And again, I think it's important for us to know that it is professionals who are involved in the work. The information is only provides, partial idea. If you can't just understand the whole thing by just looking at the digital models, it's important to talk to people. So sometimes the meaning can be lost. We just see the digital model. And it is a concern because a lot of people just see the model and say, oh, we got the information. It is not. All the other things about the project, about those models and the information and the numbers, there is someone who's designing those things. And that is important for us to understand. It's important for us to talk to that person and get them involved in the projects. The other problem is that if you put inappropriate data, you get inappropriate answers out of it. And if you have an inappropriate purpose, the data is not going to help you out of that. So if you provide information about the structural integrity of the building and ask for cost information, they are not going to produce cost information. So it's important to understand what information is needed and what sort of a data needs to go in to produce those information. Of course, with all the models, there is a security issues. Some people can hack into these things. So this is an issue that is becoming a major problem in some of the smart cities or so-called smart cities. So for example, if the hackers get into or get access to a digital model of a city, And let's assume everyone in the city has a kettle that is with a sensor that you can operate online. So you use your phone and put your phone and say on your phone, oh, heat the water up, I'm coming home. And automatically the kettle heats. You can do that nowadays in the UK. And there are smart cities like that, which does those things for us. So for example, if you want a nice hot bath, you can, on the way, you can say, I'm coming home, prepare the hot bath, and the water and the temperature and everything will be automatically governed, and things can be done automatically from home because you have connected your home system to the national, the internet, and the internet connected to your phone. Now, hackers can hack into these things. If they hack into these things, someone told me this one, that if they switch on all the kettles in a city at the same time, the energy grids will normally break down. I'm not talking about major appliances. I'm just talking about a simple kettle. But if every kettle in the house is turned on, it can break down the whole system. So there are several security issues when we start connecting to the major systems. But of course, any modern digital improvements that we make has security issues. You put your data and information on Facebook freely, you put your data freely on information, people can hack in and take that and use it. That's a major problem. But we are taking that security, as, well, this is okay. But these are some of the issues that, we can come across. So furthermore, there are issues about data. There are open data related issues. There are also issues about what are the deliverables, when it can be approved and things like that. I'm going to use a practice case so that I can explain a bit more about the case. And I can give you some examples about that. So let's move on to that. Before I go there, I think this is a very, very interesting one. How do you know that you are looking at a digital environment? Sometimes the digital is so similar to, what is actually happening in practice. When you are on a screen looking at these things, you are not sure that it's a digital environment or actually the real world. So the question is that, can we actually trust the data? A lot of people are worried about that, so that if someone says, sign off this one to say it's structurally sound, you're not quite sure. You want to do a bit more work than doing that. So instead of producing all engineering checks, maybe you will audit things and say, oh, okay, this is okay, because I have audited to say this is okay. Because a lot of functions that you normally do as engineer could be automated through building information modeling. However, it needs checking. You can't just sign it off. So your work is not there, disappearing, is always there, but it becomes much more specialized skills because you are auditing rather than doing. I think that's the difference in it. So what I want to do is I want to spend the next 10 minutes looking at some of the projects that I got involved. I'm not looking at so many. I'm only going to look at few projects I got involved, and I'm going to keep it short. But I'm going to give you some examples of what happened, and so that it gives you an idea of how this works. So I got involved in 3 different university building projects. It's in Birmingham. One is called Parkside Building. The second one is called Curzon Building. Another one is called Birmingham Conservatoire. All these buildings are very much completed now. They have BIM models and they are in operational stage of the building. So before I go into this, I'm going to show you one of the buildings and how that building was built. Okay, so pardon me, I'm going to switch from one to another. I thought I got the correct one. Sorry. So let me open this. Okay, and I don't think you can see that yet. Give me a second. Let me share it. Okay. So I hope you can see this screen. So this is a video of an actual construction of a university building. Can you confirm whether you can see it? Anyone?
Yeah, can see it.
Okay, brilliant. Thank you. So I'm going to run this one. This is an actual building construction. So this is not a digital model. Okay. So this is an actual building construction. You can see what is happening there. There's no sound, so don't worry about that. So this is we had a camera. It continuously sort of, captures work that is happening on the project. I hope you can. Sorry, can you see it's moving?
Yeah. There's a little bit. I think your coverage is a little bit problem. Can you switch off your webcam? Then I think it is easier to view that video.
Yeah. Okay. Is it better?
Yes.
Okay. So you can see the ground floor is going up. They have put a crane to start the building. You can see baby dumpers and various other things moving on. So here you can see something is growing up, and we are using what they call a slip foam building. So it just goes few centimeters a day, 10 centimeters a day. You build slowly. The core is built like that. And you can see they have finished the core. They are starting the external. And then now they are going to the second floor. Second floor is getting concreted. I'm going to skip few seconds because, you can see if the first floor is complete, the work is still ongoing. The concrete columns are coming up. And the next floor will start coming up from there. So you can see the next floor is being built. There are some construction joints, so not all the floors are built at the same time. So I think there are 3 construction joints here. You can see there are 3 bits going at different times. We go to the next floor. So you can see floor by floor, things are going up and people are finishing it. So this area that you see at the very front is an auditorium. So you can see they have taken 2 floor space to build an auditorium. And you can see how they are building the auditorium with the columns on the back and the steps on the side. And what you see on the left-hand side is the connection bridge between the existing building to the new building.
Excuse me.
Go on.
I think there's an internet speed is a little bit slow. Can you pause and play the video? Yes,
Yeah.
Wait. It's not moving in our screen.
Yeah, it's stuck. I paused it.
Yeah, you play now it's okay. Play and wait for a while. Then like that, if you go, it's easy.
This is a bit fast. Okay, so we have actually this is what we call time lapse. You can see the last flow is coming up. It's finished now. Okay, so what you see here is I'll post the one. So what you see here is that almost all the internal work is finished. Now external walls need to go up, and once the external walls go up, then you have the internal work to happen inside the building, which you will not be able to see from this camera. So you can see the external work is getting finished. Now you can see the walls are being done, the windows are going up, and now almost the whole external part of the building is finished. And now you look at the last bit of it. So now the external bit is finished, the internal bit is happening. And what you see outside, what is happening outside the building is the cladding coming on the building. Okay, so people are sort of adding claddings and sort of struts and claddings, and they're all coming up. So you can see I've finished the but. So get back to, okay. Okay, hope you can see, I'm back to my presentation. Okay, so I gave you that example because I want to show something slightly different later. So that's the building we are talking about. Inside the building, there are lots of different models and things like that. And what I'm showing here is part of the building where you can see some of the electrical and plumbing work. You can see some of the tabletops, and you can see the struts and things going up. So this allows you to coordinate those things. We use something called BIM 360. It is almost like a chat function. So people could say, this is missing, that is missing, or that part is missing. And then you can see bits and pieces. You can break down a piece and see what needs to go in, how to fix it. Some of the models that you see comes from manufacturers. So they provide the models. You don't need to model it. Manufacturers provide a BIM model. You just put that model here. So things like that you could do with modeling and coordination. And on top of that, if I go to the next one, other one is about information. So if I click on one of those things, and it will provide you this information. It tells you, about, this electrical component, what is in it, what is the dimension. You can even go and find out where the further details are about that building. So objects that we talk about in models have information behind it. You can also look at certain parts of the building and the models and use those models to actually print them. So in this particular building, we printed certain parts, we printed certain coverings, 3D printed certain coverings based on the model. And it is possible to do that manufacture. So we say design to manufacture. So design it, send it to the manufacturer. This was on a small scale, but if you want to do it in a large scale, like what you see, you can actually contact a manufacturer, and the manufacturers will manufacture that component for you and then come and fix it in where it goes in. You can also bring in 2D and 3D information together within the environment. So if someone wants to look at certain types of models and sheets, so maybe you have colored those sheets, you can put those things as part of the references so people can look at that and make sense of it. You can also do a 4D simulation of the building. So you have a building, and you can sort of say, so you have a program, you have a 3D model of the building. If you connect the components to the program, then it becomes a 3D, 4D simulation, a time simulation. So let me show an example of a time simulation that we have done before. For the same building I'm talking about that you just looked at, but this is now, it's just a, it's a model, 3D model and programming. It's a time simulation I'm talking about. So let me put that. Hopefully you can see that screen. So this is the new site that we talked about. The video you saw earlier is this area. That is how the first thing came in, if you remember. The next thing came in, the flows are coming in. It's the same building we are talking about. Now this is connecting components to the program. Now the interesting thing happens is actually this is a project we did while this building is being built. So this is in 2012 we did this project. When we did this, at some point we modeled this one, and on that particular week we stopped and then we looked at we found that even the cranes were, it wasn't planned, but the cranes were looking at the same side, but that wasn't planned, but it just happened. But you can accurately model it if to a certain extent. If the project is not delayed, you would know when it is happening. I'm just giving you an overall view. You can actually go in and look at what is happening inside the project. We used a software called Synchro to do this. If you are working in infrastructure project, now Synchro has become an infrastructure project, because infrastructure projects, there are a lot of unknowns. You don't know how you are going to do the work. You know, it's not like a building project. So you have to actually do some work to actually do some construction work. So that preliminary work can be captured, and Synchro as a software allows you to capture those things. So let it play this through. So the green bits are to show that the work is happening. White bit means it's finished. Now you can see, well, I don't see any green bits. Is the building finished? External bit of the building is finished. It's still going because the internal works are happening, and I haven't zoomed in, so you can only see the external bit of the building. But you can see how it is connected to the building, where this building is. It's a good way to connect. Okay, it's a good way to connect those things together. So let me go back to my presentation. So you can see, as you can see, 4D modeling is possible with that. Similar to that, you can do cost estimation by looking at these things and put the prices on it. I would do, actually, there's a separate software. Normally, I would do a separate software, but still take the information from the model and do that calculation. So it is still useful, but not in the same, environment. This is a project we did. We got involved in Sydney Opera House facilities management work. So we have a 3D model of a BIM model of a Sydney Opera House, and then we talk about how you can manage spaces within that. So it was a it was a client paying us to do a bit of work from my current university. And of course, it also allows engagement. What I mean by engagement is that when you have this 3D, so this is not a real picture, okay? This is a virtual, digital picture, a picture taken from BIM model, how realistic it is. So you give this one to someone, say, for example, you are consulting doctors and nurses about how the patient beds are going to look like. You can provide something like this and talk to them. They may say, well, we want the parapet wall to be much more, smaller or much more larger. We can talk about these things because there is an environment, it's almost like a finished product, and within which you can then engage with the stakeholders to improve its performance. So these are some of the things that we did and we can do with BIM and BIM models. And there are, this is one of the things that I haven't actually, this is other things that you could do with BIM models. And nowadays there are 3D lasers. You can do laser scanning and of the existing models, existing buildings, scan them. When I say laser scan, you don't need to actually go and do everything. You fix the scanner in a place, let it scan, and it scans the whole building on its own. You do a few points like that and bring them all together in a software, in a work called point clouds. And using that, you can construct a 3D model of existing buildings. So you don't have to just use it for the the new buildings. You can use it for existing building. That's what we did here in this particular building. It's building X was built in so many years back. We used that laser scan to scan the building and use that scan for other purposes. So you can do so many other applications with it. I'm not going into details of those things, but that's the advantage. Once you have an information model, you can use it for various different purposes. So some of the things that we found, and I want to finish it with this, some of the things that we found in this, in the projects that I got involved, is that BIM is a very good tool when it comes to structuring information, communicating with people, and calculating tasks and collecting information from projects. But we need to be mindful that it is not the project, it's not the building, it's only a digital model of the buildings, hence it only provides a partial information. The problem is that a lot of people get seduced in this in this 3D environment. It looks cool, you know, so everyone is into it. Oh, this is brilliant. It is not. It is not brilliant because it is cool and nice looking. It is brilliant because it carries information behind it. So as engineers, we need to see the content, the things behind that model, rather than the seduction that comes from the 3D environment and the model that you see it. But when we did the work, one thing that we learned is that only ask for necessary information. Just don't go about asking for all information. But if you are using in BIM, it needs active management. The BIM model and the project needs active management. So that's very important for us. But even though we are talking about technology, from the projects, what we learned is that this is about people rather than about technology. It's about making people understand what is possible, what could be done, what could we use these models for. Otherwise, the models don't have any purpose. Just producing a model doesn't give any meaning behind it or any purpose behind it. It's people who make that purpose and meaning. So it's about communicating to that people and understanding what they want out of it. But what we understood at the end is that we cannot work in the same way that we worked if building information modeling is coming into practice. We need a new way of working. We need a way of connecting digital information together with physical information with people. And there will be some mistakes, there will be some issues. So we need to be much more pragmatic when it comes to managing and understanding things to do. So if you are new to this, it is important that you take it slowly, understand it, be pragmatic about it before using those things. There are some challenges that they're still being sorted out. Is that, you know, I said it's a parametric model. When you extend, when you increase the height of the ceiling, the walls will automatically extend itself to cover that one, which is good. But the problem is that if you have a M&E contractor modifying something on the model, that will automatically modify some of the aspects of structural engineers or other engineers. So suddenly it becomes a problem because you did something else before, but now it is a different information, not of your making, but because someone else have changed it. That is a problem. So nowadays the contracts have been done in such a way is more of a collective insurance policy rather than individual insurance policies. So it's changing. The way we work is changing. I think it is important that, you know, for me, I see BIM as a, you know, brilliant opportunity. And I think it would be really useful if you are able to get into it and start doing it, even in a small scale, to understand what it is. It will broaden your horizon. It will enable you to move to companies that are using BIM, large scale, huge companies. But it's also important that not to use BIM where it's not necessary. So ability to understand where to use, how to use is important, but at the same time, not to use, to take the decision not to use in certain places is also something that's very important. So I will finish it there and I'll open the floor for any questions. Thank you. Okay. Any questions?
Yeah, thank you, sir. I'm Pushpa Raja from Untitled Chapter. Yeah, I really got some more information, and this is new to us actually, and very useful. Thanks for your wonderful session. And I have one small question.
Yeah.
Generally, what is the cost involvement in the BIM modeling? Say, what is the percentage of the total cost? So I know this is cost saving with the quality output, and we can minimize the variations. And this is a fantastic product.
Yeah.
But what is the cost involvement, the percentage?
Yeah. Okay. That's a very good question, because I think that's a major problem, especially in countries where, you know, the license cost could be expensive, you know. So I get your question. So that's really good. That's a really good question. I think the advantage you have it. I mean, I don't have a figure in terms of percentage because it varies. Let's talk about if it is a large project, then it becomes a very small percentage, not even 0.05% of a whole project. So it could be very small in a large project, and in a small project it could be large because the amount of money is small. So it's quite difficult to say what percentage. So BIM licenses used to be about £5,000, about £3,000, £5,000, like that. It could be really expensive. However, they have changed that now. They are providing BIM licenses on a cloud-based BIM licenses. So you can go into Autodesk or some other softwares that you use, and you can buy monthly basis. So that's about £20 a month. And £20 a month is basically, it's a small amount of money, isn't it? It's probably around £5,000, 5,000 rupees, something like that. Per month is small compared to lots of other issues, isn't it? So you could actually look at it from a monthly basis point of view rather than a whole models. So the question about, so could I ask you, whether are you Pushparaj as your name? Is that correct?
Yeah, Pushparaj.
Okay. No, I thought that's Pushparaj as your dad's name. Okay. So do you work for a contractor or do you have a company?
Yeah. No, I'm working for the government contract organization.
Okay. So if it is a government contract, so that's slightly different. So it should come from the government or the contractor itself. So, and it's a question about what sort of a project they want to bid for, whether they can buy monthly licenses rather than a product as a whole. So you could try for a project, rather than, so I would say if you are setting up something, set up a pilot project within your construction company, and not too small, not too big, but somewhere in between. Buy the monthly license, work with technologists who can design it for you. You don't need to design it, but then you use it for your own work to see whether it works and to see the potential of that one. And I think it will be a good study if I haven't done that study, but it will be a good study to see that.
Okay, thank you, sir. Thank you.
Yeah, thanks, Pushpa. That's a good question. Thank you.
Thank you very much for your great presentation. I'm Amila.
Hi, Amila.
Yeah, I'm working as a project manager in the contractor side, but we also government contract. We are doing the government projects.
Okay.
My question is from where Sri Lankan engineers, Sri Lankan industry can start implementing BIM. The first question. Yeah. Actually, there are many young engineers, those who are now familiar with Revit program and Naviswork. Yeah. And they are searching on this, and even some places, even myself, we are using that Revit and Naviswork, and we are coordinating that MEP and architectural, structural. Actually, in our site, we are drawing. We are making 3D models after receiving other disciplines, other MEP and everything. We are putting together. Yeah. And with my experience, I'm coordinating with the levels and class detections and everything. Okay. That is what we are doing, and I would like to where we can implement this. And second one, even though you did not mention about this, the IFC, I think Industrial Foundation. I would like if you can explain a little bit about that. It will be great. Thank you very much.
Oh, thanks, Amila. Good questions. And I'm glad to see that you are already working on projects with using BIM. So that's a brilliant news. So you have started somewhere. So I could turn the question and ask you, where did you start using BIM? So is that your first project?
Yes, actually, this is a government project. It is for the health ministry building.
Okay.
6 billion rupees project. Actually, this is 5 million pounds, more than 5 million pounds.
Yeah,
I think it is the best place to implement this.
Yeah. No, that's really good. Okay, thanks. I mean, I think that's brilliant. So if people are looking for this, they need to look at a larger projects. Normally, in the UK, almost all hospitals use building information modeling, because as you know, hospitals are so complex. There are so many systems designed, and some of them. So, for example, you know, in the UK, you wouldn't see garbage disposal from the hospital. If you are a patient going in, you will never see the garbage disposal guys, because they work on a different route. So there are different routes and different things. So something like hospital is a very complex system. And on top of that, they use lots of complex machinery on top of that. So in the UK, we look at most of the complex buildings, such as hospitals, to use a building information modeling or BIM related softwares. Now, if someone is interested in using BIM or looking for projects to use BIM, you can see there are a lot of new projects coming in Colombo. I haven't actually seen other places, but in Colombo, you would see a lot of new projects coming in that is very much funded by foreign governments, not a single building, but a group of building, more like a development. And in those type of areas, BIM would be one of the major areas that you will look at, because they want to optimize the whole site, the whole development, not just single building. Because of that, they will use BIM to connect those things, connect water flows, connect maintenance and all other things. So if there is a large development, BIM is a potential solution. So you could look at large projects where it is happening. Second one is complex buildings. Someone could say all buildings are complex. That is true. But there are some buildings that are more complex than other buildings, such as hospital buildings, such as if you have tall buildings, 30-story building, and suddenly there are so many management systems, that is already inside the building, and that therefore it becomes complex than a normal 2-story building. And I would say those are the type of buildings that you are looking at, projects you are looking at. Now, I don't think in the UK, in Sri Lanka, I don't think people are using BIM for infrastructure work. But in the UK, so for example, if you're building a train station or if you're extending a train station, it is a large, complex work, because the train station is still in operation. You have to take possession of the site, do some work, and then give it back. So it becomes so difficult to plan and manage and all those things. So with some softwares nowadays, with Bentley and other softwares, you can actually visualize that and manage it. And therefore, if you're looking at complex infrastructure projects, again, this will be a use. But I don't think people have started using that in Sri Lanka yet. But if you go to Middle East, because there are a lot of infrastructure projects, you see airports, you see lots of road networks and developments coming in. Almost all of them will use building information modeling, because we are dealing with information and complex handling of that information. And therefore, that would become very useful. So I don't know exactly, Amila, where the projects will be in Sri Lanka, but these are the projects that you can look at. Complex, large-scale projects are what you're looking at. Now, the other question you asked about is IFC files. So I think it's not that difficult. I mean, IFC is a format. IFC is an open format that you can. So, for example, you are using Revit and you are developing a model. You want to take that model to another software. Sometimes that other software will not recognize Revit model. However, the international standard body has asked every modeling software, including Revit, to have an IFC output. IFC is a format that can be read by any modeling softwares. So if you have a model in Revit, you said you are using Revit, Amila. So if you have a model in Revit, you can save that as an IFC file. And let's say you want to use ArchiCAD, another BIM software, because there are lots of other BIM softwares, and you want to use that one, and you can actually use the IFC file to open in the ArchiCAD program. ArchiCAD may not read the Revit file that you submit, but it will read the IFC file. So IFC is an open data format that can be used in various different softwares. It has its problems. It is getting better though. 10 years back, IFC files were okay, but when you open the IFC files, sometimes certain elements are missing, but it has now become better. We don't use, not that many problems are happening, but it is still a challenge for us. It's what software vendors do. Software vendors are very good. I mean, it's very similar to, what you have. If you have an Apple phone, you want to buy everything Apple. Or if you have an Android phone, you want to buy everything Android, because otherwise it doesn't talk to each other. And it's a very similar problem in the modeling industry. And that is where IFC, open format, is being introduced so that every software can read that open format. Hope that makes sense, Amila.
Yes, thank you very much. The answer is very clear for me. Thank you.
Thanks, Akila. Oh, thanks, Amila. Cheers. Okay, any other questions? Oh, there's a question here. Sanjeevan is asking, BIM enabled us to do project management purposes. Then how about measurement parts? Is there any clarification standard for such model output and calculation? So, okay. I believe you're talking about measurement of quantities, Sanjeevan. Is that correct?
Yeah, so normally we have a standard for method of statement for the QS parts.
Yeah.
So when you are going to understanding that contextual purposes, so how much is validity is of BIM outputs?
Okay. Yeah.
Yeah.
So as a quantity surveyor, but this is from a quantity surveyor's point of view, as a quantity surveyor, they will not be ready to sign off something that comes out of a model. Yeah, because you're dealing with money. So you need to check it if something comes out of model. Now, you mentioned about standard methods, because you need to use a standard method to report your quantities and prices and things like that. Now, BIM doesn't allow, BIM structure, we call it object-based structure. BIM structure is not the standard methods of measurement structure. It's a different structure. So you need to, so that's why I said, you may have said, I said that I would normally use a different software, take that information, measure that information, and put it to a software, So I wouldn't do quantities from the model itself. I will use the quantities. For example, if you want to find out the ground flow area, you could easily find that ground flow area by just clicking the ground flow and looking at the area. So that is fine. The problem is that how and where you put that information in the standard structure is not provided by BIM. So there is a software called CostX. I don't know whether you have heard that one. The CostX allows you to do that part. So you can bring the BIM model within CostX and then take the quantities out from there, then to produce the model in a standard method of measurement structure. So it is possible, but I would always check it, audit it before signing it off.
Okay, sir, thank you.
Okay, cool. Any other questions? Okay, I think those are the questions I have. If there's nothing else, Raghu?
Yes, okay. If there's no more question, we can wind up the session. Arangan?
Yes. Good evening, all of you. This is the time for the vote of thanks. We would like to thank everyone who made this event a success. First of all, we thank the resource person, Dr. Niraj Turaraja, for his valuable time with us and knowledge sharing. This was very useful for us. This is very new. Then we got to know a brief idea about the BIM. Thank you so much. Also, we thank all the participants for their active participation, and hope it may be continued in the next events too. Once and for all, we thank all who participated in the event. Thank you so much.
Thank you, everyone. Bye-bye.
Okay, bye-bye. Thank you, Niraj.
Thank you, sir. Thank you.